Okay, we're going to take a look at a real world example because correlation is something that's really done quite frequently in statistics, but it's never done with theoretical values. It's usually always done with real data. So data taken from a true sample. And very rarely are you ever going to see real data that is perfect. In fact, it's impossible. Real data will never form a perfectly straight line. Okay, we're going to use the data in the table to calculate the correlation coefficient R to measure the strength of the relationship between the two variables. Okay, and the data in this chart was gathered from 2005 using the Earth Trends website, and that's the Earth Trends website if you want to see where the data came from. And here's the chart, and this is on the handout you should be working from. We have countries, and there are 12, I think, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 14 countries. We have the average length of schooling in years of the population. So on average, how many years do members of the population go to school? And Australia is pretty high at 20 years average. And then we see some low scores, some scores in the middle. Spain, Sweden, United States. Okay, so this is the average length of schooling, the number of years that the population generally will attend school. And then we have the life expectancy of the population. Okay, so we have life expectancy. We have some high values, we have some low values, some average values. Okay, so we have an X basically and a Y for each country. We're going to put the X values in L1 and the Y values in L2, and then we are going to run linear regression. So let's take a look at putting these values in L1 and L2. So I'm going to quit this screen. I'm going to press Stat, Edit. Okay, I can delete the data values in L2, and I can delete the data values in L1. Okay, so in L1, I'll put 20, 14, 12, 11, 6, 10, 13, 10, 14, 9, 13, 16, 16, 16. Okay, in L2, 80.4, 63.9, 46.6, 72 is the same as 72.0, so no need to put the 0.0. 50.7, 57.1, 74.9, 62.9, 71.3, 43.4, 53.4, 80, 80.1, 77.4. Okay, we're going to run linreg ax plus b on this data. So press Stat. Move over to the Calc menu. Go down to number 4. Hit Enter. And our X list and Y list already have the correct lists, so you would change this if they were different for you. Leave frequency list and store regression equation blank. Move down to the Calculate menu option and press Enter. Okay, and here's our output. Now we will talk about A, B, and R squared later, but R is the correlation coefficient that we're after right now. Correlation coefficient is not negative, it's positive. 0.75799, etc. And if we were to round this to 2 decimal places, it becomes 0.76. Okay, so 0.76 is the correlation coefficient. Okay, so we are going to round the correlation coefficient to 2 decimal places always. And you'll see this on your web work homework. The web work homework will be made available after we complete all of Chapter 4, which will be the next lecture. So this homework is not available to you right now, but it will be available after we finish the second lecture on Chapter 4. What type of correlation is this when R comes out to be positive 0.76? Okay, there are 3 types of correlation. Again, remember positive, negative, and no linear correlation. So since its R is positive, we're going to say it's a positive correlation. So you may ask at this point, how do I know I have no linear correlation? Like at what value of R do we say that it changes from positive to no correlation? And that's a question that we are not going to be able to answer at this time. It's something that we'll talk about later at the very end of the semester, where we actually will judge at what point we can say something has no linear correlation or positive correlation. It's not something we could answer right now, so we're going to have to hold off that question. But we will come back to it, and we will be able to answer it, both on the negative side and on the positive side. Right now, we're just going to assume that anything that comes out positive for R is considered a positive correlation, and anything that comes out negative for R is considered a negative correlation. So let's look at the scatter diagram. So how do we do that again? Let's remember that our scatter diagram is set by going up to stat plot. So second stat plot. Okay, number 1 is on, and it really is all ready for us. It's on, its type is set to scatter diagram, its X list is L1 and Y list is L2, which is where our data is. So that's perfect. If we press zoom and number 9, there's our scatter diagram. It's definitely not a perfect correlation. Like we saw that R didn't come out to be close to 1. So because it's not close to 1, it's not going to be looking like a straight line from left to right. But there's clearly a grouping of low data values, low X with low Y, and high X with high Y. You definitely should see some sort of grouping of these points as we move upward from left to right. Okay, so we can see that the dots move upward as we look at this diagram from left to right. There is definitely some correlation there. And that's why we know it's not 1, and we know it's not 0.99, it's not even close to 1, but it's definitely positive. Okay, it's not a perfect positive correlation because the dots do not form a straight line. Very, very rarely will real-world variables form a perfect linear correlation. So what we're looking at is what's expected when you calculate real-world correlation data. It's expected to look like this, and it most definitely is not going to be a straight line. So we're going to take this example a little bit further at the next lecture, where we discuss a little bit more about what the data means and how we can work with it. But at this point, we're going to end this part of the lecture. And if you have any questions on what we did, which was being able to create scatter diagrams, recognizing positive, negative, and no correlations, calculating the R value, the correlation coefficient using your calculator. This is just the intro to the chapter, so we'll still have more to do with that. But if you have any questions, you can ask me through email or the discussion tool. Another thing that I would recommend is using the practice examples from the text to get some practice on this half of the chapter so that you're better prepared for the next half when you'll have your web work homework due. Okay, so I'll see you at the next lecture.